Hello, welcome all of you to this code walkthrough session of week 6. In this week, we will see some ideas of data structures and how Java actually implements them and using them in our program. So before going into the coding part, let us briefly discuss a few points which is very essential for this week. And the first point is your importance of the programming data structures and algorithm course, right? So we know that PDS is not a prerequisite for this course, object-oriented programming with Java course, but particularly this week's content is such that the collections framework is basically the Java's implementation of data structures and how different data structures are implemented inside Java, right? And how we can use them. So associated methods, the way that we can use these data structures in our program. So that's what collection framework is. Collection framework is nothing but a framework of all the data structures, different data structures, their implementation, and which also allows us to modify, customize this data structure according to our need, right? So to understand the collection framework and to appreciate it properly, we must also have a fundamental understanding of the working of these data structures internals, right? But that is not within the scope of this course. So we would very much appreciate you if you can go through a little bit of data structures content, or those who have done PDSA before this, they will be very much comfortable. But for others, maybe we would ask you to go through a little bit of data structures related content, or you can ask in live session some details, some doubts that you might have. Okay, so that is the first point. The second is what we will do in this particular code walkthrough session is at first we will see the structure of the collection framework, because the first two lectures in this week is regarding the structure and why the collection framework is made in the way it is made in Java, right? So why it is the way it is. So we will see that the collection framework structure. We will go to different interfaces and class within the Java's pre-written the framework code, right? The collection framework code, which is basically, framework means basically a set of classes, abstract classes and interface, right? So we'll see all of those. Finally, there is something which is very important, and that is in the week 4 and week 5, we have already implemented our linked list in week 4 and our generic type linked list in week 5. Now we will see that the concrete class implementations of these, data structure, basically the linked list data structure, we will see the structure of it in the collections framework, right, which comes with Java as a part of this framework, and we will draw similarities between our implementation and the collection framework's implementation. So you will see that you have already learned the fundamental structure of how a concrete data structure class is made inside collections framework, right? So you'll be able to appreciate that fact given that you have understood week 4, week 5 content properly. And after that, finally, there is one point which I have told earlier also, that these sessions are not just for you to, spoon feed everything. This is basically to give you a proper idea of the coding part of it, because Java, C, C++, these languages are much more difficult in terms of coding than Python. So in order to give you a little bit of idea of how things work, we actually try to do these sessions. So we will not walk you through every method of collections, right? All the method associated with each collection type, but we will discuss whatever is important. So the fundamental ideas, everything will be discussed. There would be no things left which is required, but which is a little bit difficult for you to understand on your own. No such concepts will be left unanswered. But definitely we will also not walk you through every method which is there in case of each collection type, right? So that is what you have to do by going through the documentation, or even if you open the IDE and write object and then put a dot, it will give you a list of all the methods. You can just go through the definition of all those methods and you will understand what they do, right? So that is your job to do. Anyways, so now since we have discussed all this, now let's dive into the coding part. Fine. So the first lecture deals with the need of indirection, which is the benefits of indirection. Now we have already seen this in basically the interfaces, the use of interfaces, right? So why do we need the interfaces, right? So we can store multiple dynamic polymorphism, and because of this we can store multiple class instances into the same reference type in interface variable. Now the thing is how this is beneficial in case of collections or in case of data structure related program. See, the thing is, this is already discussed in the lectures by Professor Madhavan in details, but again mentioning the same thing. So the thing is, let's say you have written a program using one particular data structure, right? And then later point, because of some maybe some utility requirement, or maybe because of the size of the data that is that is given as input to the program, whatever may be the reason, you decide to change the data structure, right? There may be many such situations can arise in where you want to change the implementation of the underlying data structure. Now in such a scenario, you don't want to change everything which is there in the program. It will be very cumbersome for you, given that the program is quite big, and the, let's say, a module of that program is being also used by another program in some other function, right? So those things can be done. Now till now we have not seen any such example that a part of one program is being used in another program, right? We will see that in the next week when we discuss packages. But before that, just have a basic idea that a part of a program, a method defined inside one particular .java file inside a particular class, can be used inside another program's class. Okay, so those things can be done. So what I mean is, let's say you have a program in which you have implemented the program using a particular type of data structure, and let's say multiple different programs are also using that particular method. So internally they are basically using that particular data structure, and later at some point of time, if you want to change the underlying data structure due to some reason, so then it will be very difficult for you and cumbersome for you to go and change in all the places and modify the methods, lot of tasks, because once you change the data structure, then also you have to change the methods associated with it, right? Whatever method call you have done, all those things have to be changed. So this is the problem. So that's why the way we deal with this in case of collection is we have an interface, not one, we have multiple interface based structure. This is where we come into the which was our point number 2, that we see the structure of collection framework. So that's why how we make this collection framework in Java is there is a set of interfaces. Now once you have this interface which helps you in indirection means basically indirectly you are storing different class instances into an interface, and then using the same reference variable you can actually call the methods, because all those methods are overridden, right? So let's say there is some add method in the interface. Now you have 4 or 5 different concrete classes, each of them implementing that interface and each of them overriding that add method according to their own needs, right? So all of these classes are implementing the add differently depending upon their own needs. So whenever you call the add method, I mean the interface, you declare a reference variable of the interface, right? Interface type. So let's say the interface name is whatever, some walkable. Okay, so now you define walkable obj, and in that obj whatever object you want to put, you can put depending upon the 4 or 5 classes you have. Now when you write that obj.add, depending upon whatever object is there, automatically that particular implementation will be called, right? So this is beneficial, because see, if we come to our problem, only in one place we have to change it, right? So where we are assigning the object to the interface's reference variable, if we change at that point only, then all the method calls and whatever else, wherever that particular the data structure is used, we will not run into trouble, because all the methods are already mentioned in the interface, and that's why all the concrete classes are only overriding them. So we don't have to change the method call because we have changed the instance type or the data structure type, right? So we don't need to do that, because anyway those methods are defined, are declared in the interface, and that's why that particular object's overridden version will be called. So we don't have to worry if we change that object, right? So in one place only where we are assigning the object to the interface variable, that's the place only where we have to change, and everything will work just by changing 1 or 2 line of code. We can change the complete internal underlying data structure which is working on the data set for that program. So this is where indirection is beneficial, and this is how the collection, that's why collection framework is based upon the top tier level of collection framework is basically a set of interfaces, namely the collection interface. And so let me just go to that over here. So basically roughly drawing how this is organized, we have this iterable interface. Okay, so iterable is an interface because basically we have to iterate through any data structure that we work upon, right? So you need to iterate through them. So therefore there is an iterable interface. Now iterable interface has in the bottom hierarchy you have collection interface. Okay, so this collection interface implements the iterable interface, right? So let me write it like this. So collection implements iterable interface because we need an iterator to go through any collection, right? So okay, so we have this collection. Now inside collection primarily there is the list interface, there is the queue interface, and there is the set interface. So there are 3 interfaces, and for these 3 interfaces we have corresponding multiple classes. Now abstract classes. Now why? Just a second. Yeah, so we have this collection, we have multiple abstract classes. Why abstract classes? Because in each of these interfaces there are lots of methods defined, declared, right? Not defined, declared. Lots of methods are declared. Now if you want to make a data structure, and by implementing any of these interfaces, it will be very difficult for you because a lot of methods are there and you need to override all of them, otherwise your program will not work. So in order to deal with this problem, that I may not want to override all the methods which are given, right? I might need only addition and add and remove, and that's it. So I just want to override that, and everything else I don't want to bother myself with. So that's why from the programmer's perspective, to help the programmer, what the Java guys did, they actually came up with multiple abstract classes, and these abstract classes actually implements most of the methods which are for the referenced particular interface type. So let's say there is an abstract collection abstract class which basically implements the collection interface, and that's why many of the methods are actually already defined inside the abstract collection class. Likewise, so there are every interface in this collection framework will have a corresponding paired abstract class, right? So abstract collection, or list, there is abstract list, or queue, there are multiple abstract classes, abstract deck and all those things. Set is also, there are multiple abstract classes. The thing is, so we will not go through all of them, but after some point in between there, after multiple abstract classes, at some point then we have the finally concrete classes. So in case of list, the famous concrete classes are array list, right, and linked list. For queue also we will see them. Basically for queue there is priority queue, there is DQ or deck as it is called, also deck, and for set there is hash set and tree set. So we will see them. There is also linked asset. There are some multiple classes are there, but we will not go through all of them. Basically, go through a few. So this is the structure, and why we have made the collection framework in this form. That is mainly because of the indirection and how to use this indirection to extract. I mean, to not extract. I mean, to have the benefit of less cumbersome code when we want to change something, change the data structure, underlying data structure in the code, right? So it is basically a list, multiple interfaces with associated abstract classes, and at the end of the day we have the concrete classes. But from your point of view, basically most of you would only deal with the concrete class implementations. You don't have to bother yourself about this abstract, let's say abstract list class, abstract collection class. We will mainly deal with array list, linked list, the concrete classes. You will define one data structure using the one of the concrete class, and then you will use its method to implement your program. So this will be how it will be basically. Okay. Yeah, one important point is so you may ask that if we just wanted to implement some methods which are defined inside the interface, and that's why we came up with these intermediate abstract classes. I mean, between the interface and the concrete class. So let's say between this list interface and the concrete class, these two concrete classes, we have multiple abstract classes. So then the main motive of these abstract classes was to simplify the programmer's dilemma of implementing all the methods present inside the list interface. So why didn't we come up? I mean, why didn't we do it in the default method of interfaces, right? So we could have defined the methods inside the list interface only, or the queue interface, or the set interface, whatever. I mean, in each case, we could have defined it inside that interface as default methods, and then we could have directly come up with the concrete class version by implementing that interface. Yeah, so we could have done that, but the point is the default methods were not yet introduced in Java when the collection framework was already introduced. So because of this, there was no default methods at the point of time when collection was there. That's why the Java guys came up with these abstract classes, intermediates between the interface and the final concrete class. Anyways, but later on, actually, that's why these abstract classes are not used nowadays. You will only see the concrete classes and the interfaces, right? And then the reason is that because now you have default methods, and basically you will mostly use the concrete implementations only. Fine. So we have seen why the structure is like this. Now we will go to the code editor and directly see have a walkthrough of how these are arranged. So you see that this is the first program. What we are doing in this program is we will have a basic use of the array list, linked list, and we will see some points. But before going into that, let us take linked list for an example, okay? And see the structure of how this linked list class is implemented, right? So let us go to the linked list. So in VS Code, this is very beautiful. You guys can do that for your understanding of the Java subject properly. Just you can have a right click on each of these class names, and then you can go to the definition. By clicking on the go to definition, you can see how that particular class is defined inside the Java files. Okay, so Java library files. So that will give you a more idea on how things works internally. So let us see the linked list class. Sorry, I think there is some slowness in my system. Okay, fine. So you see that here the linked list class definition has come. Now let me just make it a little bit big. Yeah. So see public class linked list, and you see this is the abstract sequential list. So this is that abstract class, just one hierarchy above the linked list concrete class. We said that we have multiple abstract classes. So this abstract sequential list class is one of the abstract class, which is actually one hierarchy level up superclass of linked list class. Okay. So other than that, the linked list class also implements this list, dequeue, clonable, serializable. We learn these things later. These are all interfaces, but yeah. So abstract sequential list class is that class. You can go to and check the definition of this as well, and you can see that this is an abstract class, as we already talked about, abstract class, which extends the abstract list interface, right? Oh, abstract list is also again, I think, another class. Go to definition. Yeah, so abstract list is again another abstract class, as we talked about. And now if you see the abstract list class definition, it says that it extends abstract collection and implements list. Okay, so abstract collection, let us go one more level up. So this is another abstract class, and this actually implements collection. So this is the abstract collection class which I already talked about, and this is the last abstract class, or the closest to the collection interface, and which implements collection, right? Now also we can check the collection interface's definition, and you will see the iterable. Yeah, extends iterable. So iterable is the interface. So iterable is the top one in the hierarchy. If you go to iterable, that's just an interface. You can check that. Yeah, so public interface iterable, that's it, and there is an iterator which we are getting. So this is how you can have the idea of the structure, how it is there. Let me close these things. So we don't have to bother about all of this, but this is how the structure is arranged. Yeah, coming back to our linked list, the concrete class. So let us go down a little bit. You remember that how was our structure of the linked list that we made in week 5? It was a generic linked list type. So basically, like here also, here class linked list E. So there also we had this generic behavior of linked list, right? Other than that, what were the things that were important? I mean, the structural part of it. So basically, since it is a linked list, we need an iterator. So how did we implement that iterator? We had a public interface iterator. Why we needed a public interface? Because essentially I don't want the details of the internals of the data structure to be published inside the main method, and that's why I want to guard it from the programmer who is programming. I just want the programmer to use the utilities of the data structure. And in order to have this guide, in order to hide the details from the programmer, what we did was we had a public interface for the programmer to access the data structure, our linked list, by using the iterator. Right, public interface corresponding to the iterator, but the iterator itself will be implemented as a nested inner class which is private, and that's why it will only be present inside the or accessible inside the linked list class. Remember, so basically we had one nested private class which actually implements the iterable interface, right, and that class will serve as the iterator private class. So one private class was nested private class was the iterator private class which implements the public interface corresponding to the iterator. Okay, there was one method which a public method of the linked list class which used to return the iterator that one iterator object of that nested private class, because otherwise we cannot get the iterator. Since it is a nested private class, we cannot access anything corresponding to that class from the main method. So in order to at least access the methods, right, so we need a object. So that object of the private class was given to us by a public method of the linked list class itself, right, so which actually returned the iterator. We called that method of the linked list object to get the iterator itself, right? So that there was one public method of linked list class which returned an iterator type object. There was one nested iterator class which implements the public iterator interface, point 2. And the third thing was we had a nested node class, right, which defined basically the node structure, the data, and the next pointer, right? So these three things were essential. Other than this, you need to have constructors, some methods, all that is fine, but these are the primary things. And obviously the methods associated with the iterator, like has, next, get, next, all those things were mentioned in the iterator interface and they were overridden inside the iterator class. Right, so this is how the structure was. Now let us see how it is done in the Java program in the collection framework. So there will be multiple other methods also. We are not going into that, but these are just, you see, link first, link last, depending upon utilities, the different methods are given. But we would rather go into the let us do a search. Iterator. So you see, we have this method public list which returns a list iterator type value. What is this list iterator? List iterator is nothing but the public interface that we talked about. In this case, the name of that interface is list iterator, right? So the reference that we will get inside the main method while defining or while we want to get a iterator of the linked list class will be of type list iterator. So we will define list iterator x equal to whatever function name we are calling, basically this name. This small in this particular function name, right? This is the public function which will return us that particular object, the iterator object, right? So we will declare an object of linked list class. We will put a dot list iterator, which will return us the iterator type object, and that iterator type object will be stored inside what? List iterator type reference variable. This is the public interface, right? I will go after discussing this. We will go and see the list iterator. Let us see now only. Let us go to the go to definition. You see, so this is the public interface list iterator extends iterator. Fine. So this is the interface that we were talking about. Anyways, come back. And whatever it is basically returning this private nested class. You see, this is the private nested class which is basically the implementation for the iterator. So we have this implements list iterator, this same list iterator, the public interface it is implementing, and it will define the methods inside the list iterator interface. Whatever was there inside the list iterator interface. So basically this has next method, right? You see, these are all the declaration, has previous, and all these things will be defined inside this particular class. Okay. Yeah. So we will again revisit this due to another reason later on, but let us now. So these two things are done: public interface, nested private class, and one method to return the object. Other than this, we had this node class was there that we talked about. So let us see that node. Anyway, so let me just check. Yeah, private static class node, next previous E is data item. So all of this is there inside the linked list class, as you can see. This is basically the same structure, and we have this iterator also here to descending iterator. So anyways, so this is a private class for defining the node. So as you can understand from here that this is basically we have already implemented a similar but much simpler form of linked list, and this is how the linked list or all the data structures in collections are also implemented, right? So why we went through this is because mostly in the part of our code that we will do, it is based upon utility. So whatever functions that are provided corresponding to a particular data structure or collection, whatever you want to call it, we will use them and we will just see the output. That's it, depending upon what you want to do. But it is important to understand the internal structure from an object-oriented point of view. That's why we went through the code base, which we have not done earlier. But now let us come to the utility part of each of these data structure which is more relevant for you guys. So first there is an array list. Now in the lecture 2 there is an exam, all the examples are done initially at least by using the collection interface only, right? So if you see this collection CSTR equal to new dot 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 means any one of the collection. As we know, collection is a reference variable of the top interface, so it can store any particular instance type. So any one instance type we can put over here. So but the example is given using collection reference variable. In this code we are using the list. List is also an interface. It is also not the concrete class, right? It is also an interface, but it is a bit lower in the hierarchy. I have used that. The reason for that is, so what Sir is trying to discuss over here is that basically we can store these different types of objects inside the collection interface reference, and then we can, work with it by using iterator and all of that. But here the thing is, if we use a collection type reference variable, that is fine. Everything will work. So you can see that I can just change this to collection, and everything works. There is no trouble with that. Just a second. So it is fine. There was some linting error, I think. Anyways, so see, there is no trouble with it. Everything is okay. You can do that, but the trouble with this is, you can see here I am getting an error, alist.get. Why? Because this get method is not defined inside the collection interface. The get method comes much later in the hierarchy, and it is declared and defined both inside the linked list class or the array list, whatever. So I think in array list, why not linked list, in the array list class, right? So we might get this get method declared a little bit upper in the hierarchy that we have to check. You can do that. Just see that in at what level the get method comes at first. But basically, I think it is coming in the list level only. So when you get the list interface, you can get, you can call the get method from there, right? So collection doesn't have this get method, and unless and until you have that particular method declaration inside the interface, you cannot use it to show some implementation, right? So yeah, so that's why to give you guys a demo of the code, we need to add and subtract elements from the data structures. That's why I have used list. This also represents the same concept, because I am not using a concrete class reference. This is again an interface reference only, right? Just like collection, but it works because it is a little bit lower in the hierarchy, and it has the definition of get, add, all these methods. So anyways, so I have this list integer a list equal to new array list, and again over here I have this list integer l list equal to new linked list. So you can see that this is same, the reference is same, right? I have changed these two names over here again just to display you guys the utility of these two data structure, but we could have also kept it as same name. And if we would have only needed one data structure here, we could have kept the name same, and only thing that we need to do is just change from new array list to new linked list. Or if we wanted, or if we had already implemented using a new linked list, then we could have only needed to change the new array list part, and everywhere else the code would have worked, right? That is the idea that we were discussing. We need not make any changes anywhere else, because this list part is same in both the places, right? Anyway, so that concept is hopefully understood. So now we will see some just simple addition subtraction. So here we have defined an array list. Okay. Then we have this simple for loop, which is basically used for adding elements into the array list. So you can add elements into the array list using this add method, right? Add method is there. Add alist.add, and here I have called a Fibonacci function FIBI. So that Fibonacci is a static function I have declared. Just basically addition of numbers inside the array list. Okay, and then I am printing the array list by using what? In order to reference each item of the array list, I am using the get function. So to add items into the array list, get index, or not index, get I means the index position, the ith position element which you want to retrieve from the array list. So you put get and pass the value of the index from whose ith element that you want to get, and then you will get the result, right? So if you just run the code now and focus on the first part. Sorry, my system is running a little bit slow because I have something running in background too. Yeah, so the result has come. So you can see we will only focus on this part, okay, till here. So here it is printing the array list 0, 1, 1, 2, 3, basically the Fibonacci series. It is printing up to here. So this is done by the get method, and all these elements are inserted into the array list by the add method. Okay, now let us come back to the code. Similarly, we can declare a linked list, right? And again here also I'm adding Fibonacci numbers, but this time from 11 to 20, right? Earlier it was 1 to 10, I think, yeah. And then again we are printing the linked list. Now, before printing the linked list, there is something that we are trying to do, that is change every even element to 0. So whichever element from, so we have added the Fibonacci numbers from 11 to 20. I mean from 11th to 20th Fibonacci number we have added, and I want to check which of them are even numbers, and the ones which are even, we want to do what? We want to change them to 0. This is something that we want to do. So basically what we are trying to do over here is we want to display you a particular example of traversing through the linked list and making changes. That's what you will do, right? You have a linked list or any data structure, you need to traverse through it. Once you have put data inside it, you need to traverse through it and you need to make changes or derive some conclusion, whatever. So here we are basically going through that linked list and changing every even element to 0. So how we can do it? So there are two ways, as already discussed in the lectures as well. There are two ways to do that. Either you can use a for each loop or you can use a iterator. Now for each loop is a Java construct. You don't have to worry about iterators and all the underlying stuffs. You can simply write a for each loop, this extended for loop. I think not for each loop. I think this is what we call extended for loop. So you for L list, right? L list is a linked list, and L list consists of integer type item. So I write integer x colon and L list. So this will traverse through each L list item, which is integer item, and then it will, I mean, you can operate upon that. So this is what we call, I think, extended for loop, this thing, and we can use it. But the thing is, this for loop also internally uses an iterator. End of the day, it is also using an iterator. So yeah, or if you don't want to use it, you can directly use the iterator. But in this example, we will see something beautiful, and we will see that there might be situations where you can use the for loop, this extended for loop, but there might also be a situation where you need to use the iterator. You don't have any other choice, right? So we'll see that. So in this example, we are using this list, x L list, and then we are printing, I mean, simply printing it by checking if it is even, and then you can store the index and then you can set it to 0, right? So how you are doing this is that index of method is there. So this is what I was telling. We will not go through, I mean, once you try implementing these things, you will see there are multiple methods, plethora of methods are there. You can just use them by reading their definition. So here for L list, the index of is there. So in index of, you put the element. So this is basically searching the index of the x value. So x is the item, data item. So I want to check what is the index of this data item. So you write index of x. So this will return you the index of that particular data item. So if the number x is even, then I want to check the index and store the index inside temp. And then I want to use the set method of array list to change, set method of your linked list to change the index, that index position value from whatever it was earlier to 0, right? So change the temp to 0. So this is the set method of linked list. So done, and then we can say make a print. This is just a normal line print to show the output in a good way. But anyways, so that's it, simple thing. But we are using this loop, which is something beautiful, right? And then we are simply traversing and we are just doing this. But now let's do one more thing, and I would uncomment this. So this is remove every alternate element with 0 as value. So now we have changed the linked list by changing the even elements to 0. That's what we have done. Now the next task is you need to change the alternate 0. So let's say there are 5 zeros in the linked list. So basically there were 5 even numbers earlier, and we changed those even numbers to 0. And now I want to change the alternate zeros. I want to remove the alternate zeros. So those items I want to remove from the linked list, right? So that's what we want to do. So how can we do that? Again, we know the for each loop is there. We can traverse the list. So I am again doing that. So we are using that for loop list if x is equal to 0, and we need to check whether it is an alternate or not, right? We will not replace all the 0 element, right? So that's why we are using this flag to alternately, I mean, here I am doing the flag not flag, so that we can alternately delete the elements, right? I mean, so for the first element, for first 0 we will not remove, second 0 we will remove. To implement this, we are using the flag. Okay, then again the index of list, same thing, everything is same, just the, I mean, like this only, but here we are using the remove method because we need to remove it. We are not just setting the value from something else to a new value, rather we are removing that node completely. So here I am using the remove method of the linked list. Remove which particular node? This is by we are passing the index, and this particular index will be indexed node will be removed from the linked list, right? So everything looks fine. So if you run this code, yeah, so you see, if you run this code, the array list is there, it was printed, linked list came, the linked list was even printed, right? So here we have this system out linked list, and then we are basically system out each linked list values. So the linked list elements are printed, but then something happened. There is an exception in thread main, which is a java.util.concurrent modification exception. Now what is, we didn't do any, what happened? So the thing is, in this example, the earlier example where, just a second. Yeah, so here you are only changing the value. You are not making any change with the, let's say the structure of the linked list, right? You are only changing whatever value was there inside some of the nodes of the linked list. So that was fine. But what is happening over here is, in this particular code, is you are removing a particular node. This completely removes a node, right, from the linked list. So if you are doing that, and concurrently at the same time, you are also traversing through the linked list. So try to understand this. The for loop is basically traversing. This for loop is basically traversing through the linked list. And while you are traversing through the linked list, depending upon some conditions that you are checking, you are removing one node from the linked list. So this is not allowed. This is, I mean, in Java, this is not allowed because, and that's why we are calling it as a concurrent modification. Why concurrent? Concurrent means when two things are happening parallelly. So why parallel or concurrent? The reason is one first is you are traversing through the linked list, and secondly you are modifying the linked list in parallel. So that is not allowed. You can either traverse through it or you can modify the structure of it. I can just simply write list.remove and put an index. So it will remove one of the node, that index node. But if I'm doing the same inside a for loop, in which the for loop is used for traversing through the list, then I will get into trouble. So if I just move this line outside, outside this loop and write this, then it will be fine. No exception will be thrown. But if I'm writing this line inside the for loop, then the for loop, what happens over here is basically the remove method, right? The remove method actually removes the element. So if you see the definition, it removes the element at the specified position in the list. So that is fine. But this also uses an internally, it is using an iterator, right? And this for loop, as I told you, it is also using an iterator. So since both of them are using the iterator and there is a clash between the structure, how the structure of the data structure is there, because the iterator needs the size count, right? How many nodes are there inside? We have implemented iterators on our own in week 4, right? So you know that we had that size variable which we are subtracting when whenever we are deleting a node. So iterator uses this size variable. So so if you are running the iterator at the same time, if you are deleting a particular node, right? So this delete will not change that size per size variable, right? So because of this, iterator will get into a mismatch. It will not understand what's happening, and that's why a concurrent modification exception is thrown. Right? So this is not allowed. So how to deal with this? Very simple. The thing is, here we are removing using what? See the variable before the remove method. We are using the list. List is the linked list. So we are using the remove method of linked list. And what is the basic trouble? The trouble is we are removing a node, modifying the structure of the linked list. Because of this, the iterator is getting into a trouble. Why? Because the iterator means the internal one. You have not written an iterator. The for loop is internally using an iterator. So that gets into trouble because since now you have removed it, there is a difference in the size. But that is not reflected inside that iterator size variable. Right? So in order to make that change, if we make that change, then it should be fine. So therefore, the idea is whenever we are trying to traverse a link or any data structure and also trying to modify the structure of it by deleting or adding nodes, you should always do it with the methods of an explicit iterator, not by using for loop. Why? Because the methods of those iterator, that iterator, it will take care of that size thing, right? Because that size variable, or the mod count variable is only accessible to that iterator class, right? Now the remove method of there. So what I mean is there is a remove method for iterators as well. We will see that in the next part of the code, and that remove method handles this concurrent exception. So whenever there also exception will generate, right, because of the removal of the node, but it will handle it. How it will handle it? It will just modify the size. So that's it, right? There was nothing else is there. We need to modify the size, and once the size is modified, then I will not run into any trouble, right? So since you are removing the element while in the traversal, you need to also at the same point modify the size of the linked list. So that is being taken care of inside the definition of the remove method of iterator, but not inside the definition of remove method of your linked list. But here we are using the remove method of the linked list. You see list.remove is used in line 42, right? So that's why it is not taking care of the concurrent exception and concurrent modification exception, and that's why that exception is being launched. So you see there is so therefore we see this util.concurrent modification exception, and in order to deal with it, we have already understood the trouble, the problem, and in order to mitigate it, what we will do is we will write the code using iterator's remove method. But I cannot just directly get the iterator's remove method without having the iterator, so we need to first get the iterator. So this is what we are doing now. So list iterator, I already told you that we will write list iterator over here, and why we have discussed that. ITR equal to list.list iterator. This method definition we already saw. So that's why I walked through the code base at first, so that these things should be understandable to you later. So you have this list.iterator. Now this boolean flag, same thing, the earlier flag. Now we are using the while has next, because these things now we have to implement, as in the slides also you can see sir has discussed this while has next on these kind of methods, right? So while itr.has next, by using the next, I am calling the next element in the linked list, right? So what is next method doing? Next method of the ITR is returning the next element of the linked list. So now since I am just starting the loop, therefore the next element will be the beginning element, right? So that is stored. Now if that element is 0, you then use the itr.remove. So there was list.remove, remember? Here we did using list.remove, but now we are doing itr.remove. Now another thing is there, in the list.remove we mentioned the index value. Here we are not mentioning an index value. So which particular element will it remove? So the idea is, since now we are using an iterator, whichever, so the definition of remove method is whichever element or node was last returned by the next method, that node will be deleted by the remove method. So this is the definition of remove method. Remove method of iterator will always remove that particular node, which node is last returned by the next method. So you know next method, so you see this line 360, next method is basically used for retrieving one data element from the linked list, right? So whichever node it is returning, the next method is returning. Later on, whenever I am writing the remove, that remove will delete this node. So every remove will delete the node which is just which is returned by the next method just before that remove method. Okay, so you see in line 63 the remove, and the latest next method is at line 60, and that particular node will be removed if the starting value is 0, right? So if you can see the definition over here also, that removes from the list the last element that was returned by the next or previous operations, right? Okay, so now we are using this remove method to remove the element, and then we are printing the modified list. So now if I print the list, you can recheck. Right, so linked list, this is the linked list that we got. Modified linked list, alternately we will be even numbers will be converted to 0. So this is even, 144 is even, so this is 0. 610 is even, so this is again 0 after 377. 2584 is even, so this number is also 0. 4181. Right, so this is done, and now I want to remove the element. So modified linked list with iterator will be, you see the first 0 will not be removed, so you see the first 0 is here, but after that this 0 after 377 is removed. So 987 and 377. Again this is another alternate 0, so this is also not removed, as you can see over here. Right, so things are working, there is no trouble. Now if you are interested, I will not discuss it in detail, but if you are interested, you can see this. I will just see the remove method of this is inside your list iterator.java. You see the remove method definition is there, but if you go inside the linked list, so here if I go inside so if you go inside this list ITR, it is implementing the list iterator, right? So you see the this class we have already visited earlier, but let us check the remove method definition. Yeah, you see the remove method over here. This is the remove that we are calling itr.remove, right? You see this check for co-modification function. So if you go to the definition of this function, you will see that this is where this concurrent modification exception things are done. Right, now we don't have to go into the details of it, how there are multiple other things as well in details, but we are not going into that. But basically see that this remove method is actually handling, and you see the mod count is also getting changed over here. I mean, there are multiple other aspects of it as well, but we are not going into that. But basically I wanted to discuss that you have this concurrent modification exception being taken care of while you are working with the remove method of the iterator. But in the linked list remove method, right, this is the iterator's remove method, right, and linked list also has a remove method. So this is, so please don't get confused, as we have already seen, this is inside the class, this list itr class, the iterator class, that remove method, right? If I go down, you see the remove is over here and there is no parameter. But the initially first remove method which we used on our program was the linked list classes remove method. So we are going out of the list iterator class over here, right? Private list itr class. Outside it we have one remove method, which is the linked list classes remove method. So yeah, so you see that this is the remove method that we are talking. You put the index and that value is removed. So this is outside the list itr class and inside the linked list class. I mean, list itr class is also inside linked list class, but that remove is inside the list itr class. Anyways, so these things are done, right? Okay, so now another part of it is I have not discussed all the methods inside, as I said, linked list and array list, but the fundamental ideas are discussed, all the things. You can just check different utilities by using different functions. The next thing is sorting elements inside a collection or a list. Let's say in this list, array list or linked list. So we are taking an example using array list. You can also do the same with linked list as well. But anyways, so let us discuss this sorting part of data items. Now we have array list fighters, and those of you who are interested in Ultimate Fighting Championship, UFC, you guys would be familiar with the names mentioned over here. So I'm very interested in that, so I've used that as an example. So anyways, we have this array list which have this fighter's name and the corresponding wins they have done, and I mean they got. And now I want to sort this array list depending upon the number of wins. So you see that this is not an integer type item which is very natural to sort. So unless and until I tell Java somehow to, I mean, what are the reason, I mean, what is the parameter on the basis of which these items should be sorted, Java will not be able to decide it on its own, right? Because if it would have been a list of integer and I would have just called the sort method, it would have sorted. But this is an object of a custom type, which is basically a fighter class. And that's why I need to mention the conditions of sorting, right? So how to do that? So you see, now we will, in similar situations where we want to compare between two items, there are two ways we can do that, right? The first one is by using a comparable interface, right? And the second one using a comparator interface. Now they both are interfaces. One is functional interface and another is a normal interface. So comparable, that we will discuss now, is a normal interface, and comparator is a functional interface that we will discuss in 2 weeks later. Okay, so we will discuss that also later, but now we will discuss how to mention this criterion of sorting of custom objects by using a comparable interface. So this is very important because this is a technique to have customized comparison for user defined classes, right? So what we will do is there is an interface called comparable. So as you can see, while I am defining the fighter class, I am writing implements comparable. Now comparable interface is something that I have not declared or defined. It is already there in Java, and the purpose of this interface is used to at different position, not only collection, at other places also this comparable is used mainly to provide a customized condition or criteria to sort objects or to compare between two objects. That's why the name comparable. So if I go to the definition of this interface, you will see public interface comparable, and it's a generic type. It can work upon any type of data item, and there is only one method, that is compared to. Right? So the signature of this method is a generic type parameter. It is object, basically it is accepting, and it is returning an integer. Right? So basically whichever class, so this is an interface, so any one of the class will particularly implement it. So whichever class is implementing this interface will have to override the compare to method, right? And the idea of this compare to method, the overriding idea of this compare to method is you will return a positive integer, right? If you will return a positive, that's why the return type is int. So you will return a positive integer from the compare to method while overriding it inside your class, right? So the positive integer when the argument that has been passed into this compare to method, this O object, right? If the O object is, I mean, greater than the, you will return a positive integer if the this object means, since you are implementing it inside a class, that corresponding this object will be there. So this object will be greater than the argument object O, then you return a positive number. If it is greater, this object is greater. If this object is smaller than the argument object, then you return a negative number. And if this object is equal to the argument object, then you return a zero value. I mean, the zero value. Okay. So this is the working idea of the compare to method. Now, this is a comparable interface. There are lots of things are mentioned. So yeah, comparable interface. Now here I want to have this comparable interface, and this is accepting the fighter type because it is working on the fighter class only. So I'm writing fighter, right? So fighter, string name and wins. Now I want the sorting to be done on the, comparison to be done on the basis of what? Not name, right? I could have also done it on the basis of name. Then in alphabetical order the fighters would be sorted. But I don't want that. What I want is the number of wins, right? So I will override this compare to method over here. Okay, public int compare to fighter obj. Now you can see I'm using the fighter obj here because here also I've used the fighter. Right, because that's the definition here is by generic type. So here the generic O object was there. Here I'm overriding it with fighter obj. Anyway, so I'm returning obj.wins minus this.wins. Now in this case, if this object win is greater, then a negative number will be returned. What I just told you, if this object's win, I mean this object is greater in whatever condition you want to do, you do. I mean if all the fields or the condition associated with this object is greater, then it should return a positive number. That's what I told you while discussing the compare to method rule, right? So the thing is that rule applies when we want to sort or we want to arrange things in ascending order. By default, the arrangement of sorting is done in ascending order, right? So the compare to method, if you return a positive value when this object is greater, it will sort it in ascending order, right? But here I want in descending order. So the guy who has maximum number of score will be shown at the top. So when I want to do this opposite thing, that's why I'm reversing the concept. So whenever I'm returning a positive value, that essentially means that this object is smaller. And this will force the internal mechanism of Java to sort the things in descending order, right? So this is just how it works. So that's why I'm writing obj.wins minus this.wins, right? So when this is greater, it will return a negative number, and that's why it will be sorted in descending order. So the idea is, what's more important over here is this comparable fighter, right? The comparable interface and the compare to method corresponding to this comparable interface is used to provide customized criterion of comparison between two user-defined objects, for which there is no, I mean, for like primitive type comparison is not there, like double, float, integer, long, those comparisons are not there. We are using this comparable interface. Be very familiar with this idea of using comparable, because wherever you want to compare different user-defined type objects, any class objects, you are going to use this comparable, right? So comparable, compare to method, you are returning this, and everything else is kind of same. There is also this toString method. Now, I think we have discussed it earlier, or maybe if we have not done. What is this toString method? toString method is basically a method of the object class, and we know in Java, object class is the parent class of all classes in Java, right? So the toString method is there inside the object class, and since any class is a subclass of object class, so by inheritance we get this toString method inside any class, and I want to override this toString method. Why? Because by overriding this toString method, I can just put the object in the println function. So while I write system.out.println, and inside println, if I directly write an object, right? So it will return a normal hash code. I mean, what is this hash code, and we will learn all of these things later. So basically it will print something, some numeric value which will not be of understanding for us. But if I override this toString method, then it will, when I simply write system.out.println and I put the object directly without mentioning any field, just put the object directly, println obj, right? So then this toString method, if I have overridden, then whatever overriding I'm doing, that is the way that is the format in which the println will print, right? So basically the println internally uses this toString method to return or to print to the console. So that's why I'm overriding this toString method, return, this is the way I want the object to be printed when I directly call println, right? So that's it for this function. So like as I told you, system.out.println fighters, right? So when I do this, the fighters will be printed in that manner. Okay, so we have these wins and names, and then system.out.println fighters to print the initial data structure, and then I'm using the collections.sort. So this is something, this sort method is something new. Collections.sort. Collections is basically what we are basically using this collection. If you see the definition of this collection, Yeah, so you see there is a public class collections. Now don't get confused, collection was an interface, that is without the S, only collection. And corresponding to collections, collection, we have this collections class, added one S at the end, collections class. And this class consists exclusively of static methods that operate on or return collections. So basically on those different utility methods are there inside this collections class, which helps you work with different type of collection, right? So these are things that you have to learn by practicing, you need to know. And yeah, so you have this collection, inside this collection we have this sort method defined, and this sort method will basically help you to sort the data items present inside a particular collection. So collections.sort, and inside this you pass the collection which you are working upon. So fighter is the collection. Fighters, you are simply passing the fighters collection over here, which is basically an array list. You are passing that array list over here, and it will sort the array list depending upon the type of object present inside it. If it would have been integer, it would have sorted numerically. But since it is a custom type, which is basically an object user defined type, which is basically fighter, then this sort method will see that is there any comparable definition given for the compared to method. If it is given, then I will do the sorting on that logic. So since we have done that for fighters over here, compared to method, so sort method will sort it accordingly. Anyway, so now we have done all of this. Now let us print it and see what happens. So you see that initially the list was like this, and after the sorting the list is like this. So you see that it is based upon the descending order sorting, a maximum 29, 28, 27 and 22, and on the basis of wins it is being sorted. Got the point? Fine. So these techniques are very important because see, in multiple collections when you are working, depending upon this implementing comparable interface, using iterator, these are the fundamental ideas that would be required, right? This concurrent modification error which might happen, how to deal with them. Other than that, different method utilities you can just browse through. There are multiple methods, you can use them to have multiple functions, right? Fine. So that is one part is done. Now next we will move to a little bit different data structures, which are basically set data structures. So the first part is done, lists are done. Now we will see sets, right? Now what are set? Again, I would come to the same point once again. Please, if possible, go through some content of data structures and see what are hash table, what are set, what are hash table or hash sets, what are binary search trees. These are the things that you need to know to properly appreciate these codes. But anyways, you might ask a little bit in live session as well. So here we are defining a hash set inside S1, and there are multiple ways to define a hash set. So in the second way, we are parsing an array. So this is arrays.asList. Okay, you can use this arrays.asList to pass a list of items. So how can we do that? Inside the asList method, just simply put multiple commas and pass the numbers that you want to to create as a list. So this is create as an array. So this is a way to create an array. Arrays.asList, sorry, not array, a list. Create a list. So you can use this asList method to create a static list by passing multiple elements inside using commas. Okay, so this hash set, second line number 9 definition of hash set basically takes an argument of a list. So you pass the list inside the hash set, all the element present inside that list would be converted into a hash set representation of the numbers or the values, right? So since I'm not defining any list earlier, I have just defined it in the place itself by using the asList method of arrays class, which helps me in doing that. Okay, so once that is done, then we are simply what we are doing, adding elements into the set 1. This is in set 2 we have already added using this list thing, but in set 1 there is no element is added, so we are doing it using this add method. And so basically we are representing multiple ways, displaying multiple ways in which you can add elements into a set as set. Okay, so s1.add. Now the way we are adding over here is, it is a little bit, I have intentionally done it in this way. I am again adding the Fibonacci numbers, which we have already added in case of the list. Similarly here also we are adding the Fibonacci numbers, but this might be a little bit difficult for you guys to understand. Now we are writing java2.datastructure.fibi. What is this? I mean we have not done anything like that. This is essentially the thing we already talked about. A part of a code you can also use in a different code, right? So I told you that this in the beginning of this session, that you can use a part of a code, in this case a data structure.java, this class, this file, right? If you see here, I have defined the Fibonacci method. Yeah. So inside the data structure.java program, I have the data structure public class in which I have this static method fib. Inside data structure2.java program, I am using this fib method over here, right? java2.datastructure.fib. This is the syntax because I'm hierarchically I'm going. So java2 is the package that, again, we don't know what packages are. We will deal with them in the next week. So then you will understand how this is happening. Just to keep this thing in mind, right? We can do this. We can use a part of a program into another program, but there are some rules we will learn in next week. But we are doing it over here. As of now, just understand we are essentially using the fib method, right, to add multiple Fibonacci numbers into the set, right? So s1.add is done. I have added some methods in the set. Okay, so here system.out.println s1. So I'm printing the collection. Okay, so after so by the way, according to the Fibonacci numbers, we know that the first Fibonacci number is what? 0, the second is 1, third is also 1. So both second and third item inside Fibonacci series are 1, which are similar values, and we know that a set does not allow similar values. So let us print and see whether that 1 is added only once or it is added twice. So as you can see, S1 over here in the first print statement corresponding to line 12 println statement. So S1 is 0, 1, 2, 3. So that 1 is not added twice. 1 is added only once. So this is what set is used for. It will not store multiple values of the same item twice. Got the point? Okay. So automatically it is removing that duplicate value. Then again, let's say in S1, this is for, so in S1 I'm adding 8 and 13, right? So let us see what happens after that. After adding 8 and 13, what we are doing? Again, we are printing S1. So let us see. So S1 after adding duplicates, 8 and 13. See, 8 and 13 are also there in the initially, it was also there, right? So again, since I've added once again, see, here only 8 and 13 were there, but again I'm adding 8 and 13 in line number 14. But after printing them, still 8 and 13 are only once. So it is again verified that inside these sets only once the elements are there, unique elements are there. Okay. So now after that, what we are doing is this is add all method. Add all method are used to merge two sets together. So or basically, so all the values in set 2 are also added to set 1. Right? For I equal to 1 to I and I plus plus, I am doing S1 dot add all is 2. Right? So and then what we are doing is system after merging S1 and S2 merged together as S1, we are printing the S1. It's simple. There are multiple utility functions. You can go through them and understand. Right? Then there is this contents method, S1 dot contents. So this is something which is very important over here. S1 dot contents 100. So I want to check whether the 100 item is there inside the S1 or not. So as you can see, it is returning false because S1 never had 100. You can see this is S1, right? So 0, 1, 2, all the elements are there, but 100 is not there, so it is returning false. So utility, multiple utilities, but there is one thing that is very important. This question that why another data structure just for checking if present or not? Because essentially we have not done anything new, right? And see over here, I'm coming to another data structure which is tree set. This was during done using hash set, right? So before going to tree set, since we are ending on hash set, I'm just discussing. We have not done anything beautiful or anything new, right? Adding elements, that was also done in the list, right? Linked list, array list, and add method is used here also, there also, fine. Add all is also there, also add all is there, right? And contains membership checking, that is also fine. We are checking, but I mean, so why we are just for checking membership or checking whether an element is there or not? Why we are going through so much trouble of having a different data structure? We are not doing anything beautiful over here other than the things which are already done in case of list. So see, the thing is, this is why the data structure internals are important. So the way the hash sets work is very, very fast than any normal list. So if you go through the, I have mentioned a particular tree, I think, yeah. So over here, so if you just a second, so fine. So if you come over here, you will see this thing. The time taken for checking whether an item is present in a dataset or not can monstrously vary between two data structures used to represent that dataset. Okay, suppose so this is a real calculation. I mean, similar to reality. It is not something which is just given as an example. This is kind of considering a normal gigahertz frequency machine. This is something which will really happen if you have this, if you have the data size like this. So suppose a data set of integer is 5 into 10 to the power 7 TB in size, terabytes in size. Such a data set, if represented using a list and a hash set, the search time will be 198 years in case of a list. So the contains method that you just used, right? So if you are simply searching on a list or array list, whatever, linked list or array list, if you are doing the same search on a normal array list or a normal linked list, then that search time will take you 198 years. Whereas only 200 nanosecond in case of a hash table or a hash set. Table basically, this basically hash set only. Internally a hash set is implemented by the data structure which is called hash table. So for your understanding, Java calls it hash set, so it is fine. You can say that hash set. So in case of the hash set, the contains method is only taking 200 nanoseconds to operate upon, even when the data size is 5 into 10 to the power 7 terabytes in size. But same data size when represented on an array list or a linked list, and you are trying to search the same element in that data structure, it will take you 198 years. So you see the difference between 198 years and just 200 nanoseconds. Not even a second. So 200 into 10 to the power minus 9 second, 1 nanosecond means. So basically, this is the difference that will happen, and that's why you need to understand what is working behind this huge difference, and you will understand that when you go through the PDSA course. Anyway, so coming back to our primary topic, right? So yeah, so if I go down over here, as I go up over here, yeah. So this contains method is very fast in this case. You have to understand that. So hash set is done, and how hash set is implemented internally, Sir has taught briefly, but if you guys have doubt, you can ask in live session. Now we have this tree set. The difference between hash set and tree set is tree set also prints in a sorted manner. I mean, functionally the difference that you will see, this also does not allow you to store duplicates. Automatically it will remove all the duplicate, but the thing is it at least allows, but it not only removes the duplicate, on top of that, it will keep the things in a sorted manner. So hash set was not sorted. Remember this. When you are putting data into the hash set, implicitly it is not in a sorted manner. All the elements, even it is not in a sequential manner. So what I mean is, when you are adding data into a hash set, right? Dot add, we are multiple times we are putting dot add. So it might so happen that always the order in which you have inserted element into the hash set, that will not remain same. So if let's say you are putting 1, 2, 3, 4, 5, 6, 7 like this, add 1, add 2, add 3. But at later point when you are printing the hash set, it might not be in that 1, 2, 3, 4 order. It might be in some random order. Might be in sorted order also, but most of the time it will be in random order, right? So because that is because of the internal working of the data items that you are putting inside the hash set. Okay, we will come to the internals a little later, but as of now, that's how it is. But tree set, the thing is, it will do a implicit sorting, right? So when you are printing a tree set, it will show the data in an implicitly sorted manner. Mind it, we are not using any sort function. The property of tree set is it implicitly keeps the data in a sorted manner inside it. Yeah, and along with that, since it is a set, it will not allow duplicate. That is there. So again, we are using two tree sets, just one by empty one, another one by using the hash set. So this is another constructor of tree set. You can basically put a hash set, a predefined hash set into the tree set. Right, S1 was a hash set as we have already discussed over here. Right, S1. So we are putting that hash set into the tree set. So all the data item present inside S1 hash set will be converted now into the same data with represented using a tree set. And on top of that, here in T2, which was empty tree set, I'm adding some values, right? And then I'm printing T2 over here. So since see here I have just defined T2 and empty tree set, added some value, after that, and these values are in a haphazard manner. It's not sorted. See 99, 67 decrease, 67 again 99, which is a duplicate value, which is again increase, and then 178, which is again an increase from 67, then 12, which is again a decrease. So this is a haphazard manner, increase, decrease, increase, decrease. It is not in sorted manner, right? But when I'm printing T2, you see, if I come back, you see TS2, right? It is 12, 67, 99, 178. So it is in a already sorted manner, right? It is shown in a sorted fashion, and also the duplicates are also not there. I'm not doing anything internally. It removes the duplicate as well as it keeps the thing sorted. Hash set only removes the duplicate, and not only it will not sort, it might also show the result in a haphazard manner, not in the sequential manner. In order to have that sequential property maintained, so let's say you enter 1 2 3 4, and it will keep that sequence maintained when you use another concrete class of set, which is called linked hash set, right? So you can use the linked hash set if you want the order of insertion into the hash set maintained. So so then we are also having this ts2.add, we are merging the two tree set that we had, and then again the contents method similarly like that we are checking web 13 is there or not. Nothing new. Okay, so let us see just briefly again. So before merging 8090, after merging 8090, so after ts2 and ts1 merged into ts2, so this was the condition of your tree set, right? And then before merging it was 8090. If I see over here, just a second. Oh, okay, wait. So this is corresponding to the queue part. Okay. So here we are only using the merging. Up to merging we have done. TS2 and TS1 merged into TS2. Yeah. So this is what it looks like, right? With no duplicates. And you see this is already sorted. So 0, 1, 2, 3, 5, 8. No duplicates are there, and it is implicitly already in the sorted order. Again, so we see that this is the property of reset. And then we are using the contains method, right? If it is 13, and yeah, so 13 is there in the set. Yeah. So here 13 is there. So that's why this value is coming true, right? Okay. Now again you can ask another question, that again we saw similar things only, at least tree set only one difference is there, that it is keeping the data in a sorted manner implicitly, but other than that there is nothing more. So yeah, there is not a lot of difference between tree set and hash set from a utility perspective other than the sorting, implicit sorting, but there is something which is internally it is very much different. So since here you are getting an implicitly sorted order, there is some trade-off that you have to think about in terms of internal implementation and some other utilities, right? So that is the membership checking. So your hash set checks membership much faster than tree set, right? Because tree set provides the sorted order, the internal implementation of the data structure corresponding to tree set is something different. It is not a hash table, right? So I told you hash set are internally implemented by using the data structure which is called hash table, but tree set are internally implemented using a data structure which is called height balanced binary search tree. Okay, now that is an internal different data structure. Now that binary search trees, balanced binary search trees, they keep this sorted order part, but the problem is the membership check here is a little bit slower than the hash table membership checking. So the contents method of a tree set is a little bit slower than the contents method of a hash set. So keep this thing in mind. It might be asked in interviews. Normally you will not see any difference, but it might be asked in interview, because if you are working on a huge data set, then the tree set contents method will work a little bit slower. Okay, fine. So now the next thing, we have done the set part. Now the next thing is queue part. So queue is something interesting. We told that list is there, set is there, and queue is there. These three things are there under collection. The third thing is queue. Now queue, you see, queue is a particular logical data structure. Now what do we mean by logical data structure? So logical data structure means a queue can be implemented as an array. What I mean is an array can be implemented as a queue, and linked list can be implemented as a queue as well. So the property of queue is whatever element you have inserted in the queue earlier, that should be the element which should move out of the queue first. So let's say you put element into a queue, you cannot take any random element out of the queue later. Whenever, so there is add and remove from the queue is very strictly defined. Whatever element you have added earliest in the queue, that is the element that will be removed from the queue first. So you cannot keep that element and say that, okay, I want to remove another element from the queue, and let us keep the first element which was inserted earlier let us keep that in the queue and remove any other element. If you do that, then it is no longer a queue. So the idea of queue is first in, first out. So whichever element is first in inside the first put inside the data structure, that will be the element which is first moved out of the data structure. So if you follow this first in first out philosophy, then that is a queue. Okay, and that is why we call it a queue. So whoever has come inside a normal queue first, he will be served earlier. So that's why this is the case. So now queue, if you follow this logic in case of an array, then that array is implemented as a queue. If you follow this logic in case of a linked list, then we can say that linked list is implemented as a queue, right? And what is a W-ended queue, which we call DEQ? We have already seen that. A W-ended queue or the interface under collections framework, the queue interface. So what are those things? So W-ended queue is basically you can insert and delete elements from both the ends of the queue. So let us say, as I said, one property of queue is whatever element you have put earlier must go out earlier. So another rule of queue is that the element that you have inserted must always be inserted at the back of the queue, and the element which is moved out or deleted from the queue, that must always be deleted from the front of the queue. So the first in should always happen at the back, first out should always happen from the front of the queue, right? And this is how the thing is, and internally this is how it works, because whatever comes in first will actually come and then move forward, right? One after one element comes, and the first one which entered will come and move forward and adjust itself at the front of the queue. So when you are removing the first element which was inserted, anyway it will automatically be at the front, so you remove that. Got the point? So yeah, so and W-ended queue is which provides you this thing in both ways. So not only you can insert at the end and delete from the front, rather you can also do insertion deletion at both the end. So that is what we call a W-ended queue or DEQ. Yeah. So that is there, but now since we are discussing queue, linked list can be implemented using queue as well. So that's why I have shown the example using a simple linked list only. So you have a linked list, and you can also go. This is the reason in linked list class not only list was there, but also queue was also there. You see the linked list class is there, extends abstract sequential list. We could have only stopped at implement list, right? Implements list, but now we have already implemented queue as well, DQ as well. Right? So this is the reason that linked list class can serve both as a list and as a queue. So you have already DQ and you also have the list in case of linked list. So now let's come back to the linked list class. So you have this linked list class L. Then here you see this add first. Since this is a W-ended queue is implemented in linked list, so I can do add first, add last, remove first, remove last, as I told you. So these are done. So adding at the first, removing at the last, removing at the first, adding at the last. Those functions are there. You can check that out. And here are some concrete classes of queue. This is again I am storing the same linked list, but in the reference I am changing to queue. So queue is an interface. We have already seen that, right? So I am using that queue interface reference to actually store the linked list class. Nothing new, just that we can do that. We could have already also written DQ in this place also. Fine. So now let us do something with this queue that we have defined now. So queue small q equal to new linked list. So internally it is a linked list, but we are using the queue type reference variable. So that means the method that we will use will be the method pertinent to a queue, right? That is basically which are defined inside the queue interface. So when I'm writing queue.remove, that remove method is basically, this remove is basically the queue's remove method. So if you go to the definition, you will see this remove is the java.util.queue, right? Java, sorry, not poll, just a second. Yeah, this remove. So you see java.util.queue.remove. So this remove method is not list remove, right? Don't get confused. There are multiple removes. So one remove was inside the list classes, nested iterator classes remove. One remove was there inside the linked list class itself, outside, inside the linked list class, but outside the iterator class, which is already there inside the linked list class. So two remove methods are there. Another remove method is over here, which is also, we are using internally linked list only, but this remove method is corresponding to the definition which is given inside, declaration which is given inside the queue interface. Okay, so if your fundamental idea is clear, then you will not have doubt. And what is the fundamental idea? The idea is at compile time, reference variable binding is used. So whatever is the type of the reference variable, the corresponding method type will be used. But at runtime, if you have done overriding, then the instance type version will be called. So here I have not done any overriding or anything. So therefore at compile time, the reference type method definition will be used. What is the reference type? Who is calling remove? Queue. What is queue's type? It is a queue type, right? Because the reference variable is queue type. So that way this remove is not of a linked list remove. This remove is basically queue interfaces remove method. So if I just change this to, now you see, now you come and go to the definition of this queue, you will see this java.util.linklist. See, java.util.linklist.remove. So both of these two removes are different. Keep this thing in mind. So queue.remove, right? So let us run this code. You see that we have run into an exception. What happened? Let me just rerun this. Yeah, so again we have seen no such element exception has occurred, but because of the linked list.remove first, linked list.remove, because of this Java line, 47, line number 47. So what is happening at line 47? No such element exception. So line 47, obviously this remove is getting assigned to an exception. Why? Because the queue that we have defined has no element. We have not added any element. We are trying to remove it. So this is what we call underflow. Okay, so you don't have any element. You are trying to remove it. So that's why you are getting into underflow. So an exception is getting launched. So sometimes it might so happen that here it is very evident, but in some cases when you are constantly removing and adding stuff, at some point it might so happen that you think that you have some element present inside the queue, but it is not there, and then your remove will actually cause you an error which you never intended to happen. So if an exception is launched, then it is something which is very hard. I mean, it's a runtime error that is happening. So rather than that, if you could have because it will crash the program, exceptions will crash the program, an error is happening. So because of this error, a program is crashing. Rather than that, if you could have a lighter penalty for it, then it would be better. So that's where the queue.poll method comes. So this poll method is something defined only for queues, where the poll method is just like remove. It will remove the first element. By the way, here I am not mentioning any index, right? Because we told you that in a queue, removal always happens from the front, unless and until mentioned otherwise, it will happen from the front. So poll and remove, both this method will remove element from the front of the queue. So poll method will remove element from the front of the queue, but it will not launch any exception if there are no elements in the queue. Rather, it will return a false or a null. Let us see. I think it will return false statement. So if I comment it now, rerun the code. Just a second. Yeah, so it is returning. Oh, this peak row. So basically nothing is happening. So I have not printed it. Okay, that's why. Queue.poll. Right. So now let us check once again. So you see queue.poll is returning this null value. Right? So it is not launching any exception. Why? Because you see the later part of the code is still running. So that's why it is not launching any exception, but it is returning a null value, and that's how it is a little bit less stricter. So poll method thing is, it is a little bit less stricter than remove method, and it will only launch and it will give a null value but not launch an exception. But poll is also used for removal of element from a queue, right? And similarly, just a second. Yeah, so another particular ways we can add. So the removal part is done, and then it is add is there. So queue.add, we are adding element into the queue, and queue.offer, this is also addition of element. Only thing is, like remove, add also might generate exception. So in which situation add might so in which situation add might turn into exception. So there are some concrete types inside queue which we, let's say, which we call the array blocking queue. Now what array blocking queues does, we have to mention the size of the queue at first. Before while we are declaring the queue, we have to mention the size of the queue. So in such a data structure, yeah, so as we were saying, so in such a data structure where this array blocking queue, if we define this array blocking queue, then we have to mention the size of the queue while we are declaring it, right? I mean, like in array list, we have not mentioned any linked list, we have not mentioned any size, right? But here array blocking queue, you have to define the size. Now, if you define the size, at that point later on, if you add after that size, so let's say you define the size to be 10, and while doing addition, you are not keeping track, and let's say you try to add an 11th element into this array blocking queue, then you will get an exception using the add method. So when you write queue.add 80, provided 80 is the 11th element you add in the array blocking queue, defined with 10 as the size while you are declaring it, right? So then you get into an exception. Similarly, you find this, that is what we call overflow, right? That is, it is underflow. Line 47 is underflow, and this is what we call overflow. Then again, you can run into an exception. I'm not showing that over here, but because array blocking queue is not discussed as a part of this lectures, but still you can check that out. There is just a queue interface. You can write queue just over here, queue integer linked list. Rather than writing this linked list, you can just write array blocking queue, and it will work. Okay, so this add will give an exception, but offer is basically this offer 90. Similarly, it will return a false value if it is not able to add elements. This offer is used for adding element, just like peak, not peak, just like poll was used for removing element without throwing an exception, this or error. The offer is used for adding element without running into exception or error in case of overflow. Got the point? So offer will try to insert. If it is not able to insert, it will return a false value or null value, and it will stop it, but it will not stop the program, right? The program will proceed. So add and remove, problem is they throw exception. Offer and poll, they don't throw exception. It will be unsuccessful operation of removal and addition, but at least they don't throw exception. Okay, fine. Then we have this peak method of queue. Peak is used for returning the top element. So whichever element is there in front of the queue, right? You know that removal always happen from the front of the queue. We told that. So that's why peak, what it will do is it will remove element, not remove, it will show you the element which is at the front of the queue, right? So if you see the peak method, retrieves but does not remove the head of this queue. Retrieves mean it will show you, it will return the value, you can get the value, but does not remove, it will not remove it. Poll will remove it, right? But it will not remove the head of this queue, right? So that is the peak method. And then we are using some merging as we have done in other data structure, and then again some offer and poll, you can see that. Okay, so Yeah, so you can just simply some addition and subtraction of element into the queue, you can check that. And after that, what we are doing here is we have a priority queue. Now, what is priority queue? So this is another concrete class of queue interface. Now, DQ interface. Now, the thing is, priority queue is basically internally implemented as a binary heap. Now, what is heap? Heap is again a data structure. So you will learn that in PDSA again. So what priority queues are used for is basically when you want to very fast, you want to get elements one after the other, which is based upon any particular field. So let's say in your computer, really in your computer, when you have multiple processes running or multiple programs running, your operating system will provide each of those programs with a particular value, which is in Linux, this is what we call niceness value, or you can say a priority value. So all of them will have a priority value, and that priority is what? That priority will define the importance of the running programs in your computer. And because depending upon those priority, whichever program has higher priority, the scheduler will schedule that particular program at first to the processor, so that that program gets executed at first, right? So this is how things work. This is a real example, but in, let's say, in any case, you want to implement a program where you want to have priorities given on some field basis to different element, and you want to work upon those priorities very fast, right? So you want, let's say, immediately in the program you are running a loop, and in that loop you are every time you are basically retrieving the top priority element from that data set, right? Something like that. So this kind of situation, your priority queue will help you, right? This priority queue, we have this uh, poll method, priority queue2.poll, this poll method, just like previous case queue poll method, what it was doing, it was removing from the front of the queue, right? Front of the queue. So poll is used for removal, right? So here also the poll will remove the element from the priority queue, just like in a normal queue. But the thing is, here the removal will be happening on the basis of priority. So whichever element has the highest priority will be removed first, right? And you can set, I mean, if it is an integer, so like this, in this case here priority queue is on the basis of integer. Now integer is by definite, it's the integral numerical value is enough to declare, I mean, to have the priority set. But let's say if you make a priority queue of some custom type object, so then you have to mention that on the basis of which field you want to set the priority. And how can you do that? You can do that by using again the comparable interface, as we have discussed. So the comparable interface, whatever value you give, that the maximum, I mean, by that positive returning positive value, negative value, zero value, right? You can do that, and you can mention the priority. So this is the field which is the priority value, right? So anyway, so there it is. Here we are doing using integer. So you have these integers, then you are normally adding and subtracting in line 67. Sorry, not subtracting, you are adding element into these lines, and then printing the value. Peak is again the same thing. It will just show you the top element. Okay, and then until the queue is becoming empty in line 70, priority queue dot is empty. So is empty is again a method. So these are new methods. You can just check, as I told, there are multiple methods. So if you want to iterate through the priority queue, what you can do is have this queue2 dot is empty, not is empty, I mean. So we have a not sign, negation sign at first. So priority queue dot is empty. So unless and until it is getting empty, you are basically printing the poll. You are calling the poll method, and you are basically printing it. Poll method will do what? It will remove the most priority element from your queue, and it will also return that element. So since it is returning, you are also printing that element, and every time the queue size will decrease by 1. And only when it becomes empty, the is empty method will finally give you false true result that yeah, it is empty, and then your while loop will stop, right? So but the thing is, priority queue's beautiful part is what it does is the poll method in this case, unlike in a normal queue, poll in a normal queue will remove element from the first, I mean from the front of the queue. In case of priority queue, poll will always remove the element with the highest priority in the data set. So that's how it is, right? So let us see the priority queue once to understand how things are happening. You see this priority queue 1, 12, 78, 121 and 99. And priority queue 2 is -6, 8, 53 and 22. These are the two priority queue values. Now let us see what we are doing here. Priority queue, yeah, so here system.println priority queue q2.peak, right? q2.peak we are doing. q2, you see -6 is there, so therefore the top element -6 is being printed over here. Okay. Then what we are doing is q2.until and until it is empty, you do the polling. So you take one element after it. So you see that -6 is printed at first, -6. Then 8 is there, 8 is printed. But you see now, okay, so let me just make it a little bit bigger. You see that -6, 8, 53 and 22. These are the elements inside the priority queue, right? When I'm polling it one by one, we got -6, 8, 22 and then 53. But here the 53 was earlier while printing. So what happened? The thing is, as I already told you, this is the poll method will work. In case of a normal queue, -6, 8, 53 and 22 would have been printed. But in this queue, -6, 8, 22 and 53 is printed. Why? Because the priority value is basically ascending order of the integer numerical phase value. Got the point? So here -6 is the smallest number. The priority is basically the numeric value of the integer. So -6 is smallest. So therefore the highest priority in this list is -6. Next priority is 8. So don't get confused with the order. Here -6, 8, 53 and 22 is there. Therefore this should be the order. No, that is happening in case of a normal queue. But in case of priority queue, these orders doesn't matter. It might happen. Don't see the order and don't get confused. Order can be anything. So let's say for an example I'm taking, let's say this particular after last remove, right? So you can see this particular list. Consider that this is a priority queue. Just for example, consider this is a priority queue, right? This is a priority queue. Let's say it is you print a priority queue with these elements, and this is what it is getting printed: 78, 99, 121, 12, and 600. This is how the priority queue gets printed. Believe me, you can have a priority queue getting printed in this fashion, exactly using these numbers, right? Depending upon the order you have inserted element into the priority queue. But we are not going into the details. But let us say this is the priority queue that is getting printed, and from this priority queue you just write the poll method once. So what will be the value? 12 will be the result at first, because this is the smallest element. Then again you do poll, 78 will be the result. Then again you do poll, 99, then 121, then 600. Likewise, here the poll will give you -6, 8, then 22, and then 53. That's how it is doing. So this order is not meaning anything. Okay, this order is basically, this order depends upon the way, the sequence in which you have inserted the element into the priority queue. Okay, now again you might ask that, but still it is not also in the same, it's still not in the same sequence as well. So it's not the sequence in that manner. Once you understand the internal working of heap, you will understand why the sequence matters in printing the priority queue. But anyways, what basically you need to understand is this priority queue poll method will always remove the element which is highest in priority. Now by default, the highest priority in case of integer element is the smallest numeric value, right? And if you have a default, if you have a user defined class object inside the priority queue, then you can mention the comparable compared to, and by using that you can mention which field is given more priority, and according to that the poll method will remove the highest priority ones. Got the point? Just like we did in case of hash set. So that's it for your hash set and all. The last part is your map interface. Okay, so let us discuss this. This will be a little bit time taking, just a second. Yeah, so map interface. This map is basically the first thing, which is a data structure related thing. Basically your dictionary type. So in Python you use dictionary. Map is basically a dictionary, but this map is not a part of your collection framework. So this is the first thing, which is a data structure topic in Java, but it is not a part of collection framework. So remember this: list, deck, and your basically queues and your set are part of collection framework, but map is not a part of collection framework, and but it is basically a dictionary, right? Dictionary data structure. So let us see this. I have taken a little bit cumbersome example in this case, because it will be helpful for you guys to understand map. Simply you can, map is basically your dictionary, so key value pair. So since you guys are already familiar with dictionary data structure, we have taken here just not a simple dictionary, rather the key is a string, but the value part is a list of string. Okay, fine. So here we have this hash map. The class is hash map only. We are using the hash map. There are tree maps and hash map, both are there. Again, the sorting part is different. We will see that example later in this code. So this hash map string, list of string, map equal to new hash map. So then what we are doing, the key values are the profession, and the keys are in the hash map. The keys are basically the profession, physicist, actor, and novelist. So you can see over here, physicist, right? And then over here we have actors, and then again at the bottom we have novelist. So there are three keys, and corresponding to each of these three keys, we have a list of people who are in that profession, which is Shakespeare, let's say novelist, Dickens, novelist, Dostoevsky is a novelist. So these are the novelists, and we have some physicists, Ashok Sen, Swatantra Bose, R. Feynman, and Peter Higgs, right? And actors as well. So as you can see in the list, we have added Tom Hanks both in actors and novelists, because I think Tom Hanks has written one novel, a very famous novel, and we need the item who is common in both the list, and that's why we have done that, and we will see that why. So now let us move forward, and what we are doing is we are system.out.println map.get, and inside the get we are mentioning the key. And what is the key? Actor. So this get method will return the value corresponding to the given key. So you give the key as the actors, so everything which is all the value, or not all the value, basically the value corresponding to actors will be returned. Now in this case the value itself is a list, so the list will be returned, and you are printing that list. Okay. Second, we have map.get novelist, same thing. Only thing is that we have added a get first method. So this list method get first, because whichever be the first element in that list will be returned. But these are just simple demo function calls. You can do multiple such things: get last, get first, or whatever. So you can just try on with all these functions. Now there is something which is called get or default. Now this is something interesting. So let us assume that in the dictionary, or in this case a map, you don't have the key that is being mentioned in the get or default. I'm sorry, you don't have a key. Okay, but you think that you are thinking that you have that key, but internally let us say that key is not there. So in that case, what will happen is, so let me give you this example. Now let us say that you are trying to insert a new element into the dictionary, or let's say in this map, but you are not sure whether that is already there inside the map or not. So one good option is to use this get or default method. Right. So what you can do is you are writing this, if it is there. What get or default does is you mention a key at first. So like in this example, we have used the physicist as the key. So if you have any value corresponding to the physicist key, then you are returning that value. So you will return that value, and you will completely ignore the second argument of this get or default method. But let us say that you do not have that entry inside the map, right? So there is no physicist inside the map. So in such a situation, whatever you are mentioning in the second argument, that will be returned as the resultant value. So get or default. So get me the values corresponding to physicist. If that is not there, or that is basically if that is not there, if there are no entry like physicist, then provide me the default value. So what is the default value? That is something which is I am mentioning in the second argument. In this case, it is a arrays.asList, and I have mentioned two scientists' name, physicists' names, C.V. Raman and Marie Curie, right? So that will be returned. So, but physicist is already there inside our map, and that's why we will not have this default value returned. But in the second example, footballer is used, and footballer key is not there inside our map, and that's why no footballer, this particular string will be, as a list, it will be returned with no footballer being written inside that list. Right. So this get out default method usage. Okay, so now since we have inserted element into the hash map, like by put method, and also use the get method, and also seen the use of get or default method, now we will see something. So what we are trying to do now what we are trying to do now is, can I have this pair, complete pair, key value pair associated? So one by one I will go through this key value pair and I will iterate through the hash map. So basically we have used iterators to travel through the data structures which we discussed as a part of collection framework. But in case of a hash map, it is not a part of collection framework, and therefore we are not using an iterator concept over here, right? So is there any way to traverse through the hash map then? Because iterator's idea was that it was traversing through the data structure. So now in order to traverse through the hash map one by one, element by element basis, what we are doing is this map.entry pair. It is basically a set, right? If you see this map.entry is a type which is basically a set. We will see that. So what this entry is doing, it is giving you a pair of key value pair. So the KV pair. So key value, it will return you every key value pair. So this for loop in each of its iteration is basically the key value pair. So first it will return the first key and first value pair, which is basically a physicist and the list of physicists in the first iteration of the for loop. In the second iteration of the for loop, the second key and second value, which is basically actors, and the list of actors will be returned. So in order to have this pair, key value pair, we need to have a data structure, basically we need to have a variable or a mechanism to get a hold of this, right? Now what we are doing over here is we are using this particular thing over here to define that. So it is basically, as you can see, the map.entry. Okay, this is a defined structure given inside Java, and you have to mention the format of the key value pair inside the entry method, so which is string and list of string. Now you have defined a variable of that type. And now what is map.entry set? So map.entry set is nothing but the value which is being returned, this pair value, right? If you are using that pair value inside this map.entry, then something should also return that value. So that value in that format, key value pair, is being returned by the entry set method. That's why I call that this is basically a set. So if you go to the definition of this entry set method, it is saying returns a set view of the mapping content in this map. So this entry set method of the map class is essentially a method which returns you a key value pair which is given as a set of key value pair. As you can see over here, is basically a set. We have discussed set in the previous part of this walkthrough session. So set of key value pair, right? So it is basically a set of key value pair of entry type, and that's why we are catching that into the entry type key value pair variable, and we are iterating through it. Now, as I told you, in every iteration is basically the key value pair in the ith level. So here what is happening over here is, let us see s.getValue. So what is this s.getValue? Okay, so this is a little bit composite expression. We will discuss it one by one. So what is this s.getValue? So if I just go to, so s is basically the variable. Now once I put dot over here, we will have this defined method. So get value is there, get key is there. Essentially these two are the important one: get key method and get value method. So this s, as I told you, s is nothing but a set or pairing of the key value pair. Once you write this get key method, you will get the corresponding key, and next you will get the corresponding value. So since in the first iteration the key will be physicist, so if I write s.getKey in the first iteration, the result will be physicist. The string physicist will be returned. And if I write s.getValue in the first iteration of the loop, then the list of physicists will be returned. So likewise in the second iteration, the s.getKey will return me the actors as the result, right? So that's what these two methods are there for the entry set. So here we have this s.getValue, and what we are doing is we are going s.getValue dot get last. So this basically, since the list getValue is returning the list of the professionals, and I'm taking the last element from that list. Why? Because basically I told you we have this Tom Hanks at the last, right? We want to do something with this Tom Hanks part. So let us see what we are trying to do. We have this, we are calling this get last method. Okay, fine. So get last is there, and so basically this will return the last value of all the professionals in the list. So basically this will return Peter Higgs, and this will return both of these Tom Hanks, right? And then in each of these cases I'm calling the person class. So person is basically a class, custom class that I have defined, normal person class, and with name and stuff like that, nothing in particular. So this is the person class, and we are passing the element over here, basically the name. So person class constructor basically takes the name as a parameter, and it assigns the name variable of that person. So here we are basically making a person object with the name Peter Higgs in first iteration and Tom Hanks in the other two iterations. And in each of these three iterations, we are adding the person into the characters set, right? So what is this character set? This is basically a normal hash set that we have defined over here. Okay, characters.hash set, not dot hash set, basically a normal hash set. Okay, now hash set we have already seen, it does not allow duplicates. We know that, right? It does not allow duplicates. So then I'm printing these characters. So essentially we are taking Tom Hanks and Peter Higgs and making a person object, and then putting that person object into the characters hash set. So you see that Tom Hanks is repeated twice. So these two persons are same, and the only field that I'm talking about in case of this person object is name. There is nothing else in this person object, right? Only name is there, and that's why the constructor is only taking this get value dot get last, which is basically one parameter, which is basically the name of that person. So since this is only name is there and both the names are Tom Hanks, so essentially what I want is in the set, this hash set should be able to completely eliminate the duplicate, and only one Tom Hanks should be there. So let us see what happens, if that happens or not. So here you can see these are all the previous example that we have done. So here you see this is the list that we are talking about, not list, sorry, the set that we are talking about. In this case, Tom Hanks, Peter Higgs, and Tom Hanks, twice Tom Hanks is there. Why is it happening then? Hash set should have removed it automatically. So this is where we are coming into a little bit interesting discussion. So the map part is over. Okay, map part is over. This is the way we can put elements into the map. This is the get method, get or default method, and this is the way we can iterate through the map, just like we have iterated through iterator by using the get value and all of that, right? Get value and get key, and once you have the get value and get key, you can iterate through the for loop, right? But here now we will address something more interesting. It is not related with map directly, but this is very interesting. What's happening over here is we are trying to so basically we are trying to make the hash set remove the duplicate element of the duplicate object on its own, but it is not doing so. The reason for that is internally, every time you make an object, although the internal fields are same, right? Parameters are same, everything is same. The object references, so basically it is a new object that is being created, right? Since the new object is being created, its identity is different, right? Although the Tom Hanks is this only field, the name is the only field inside person, and that is same in both the cases. But every time you are calling new method, right? In either case, you have called a new, sorry, new, not new method. The new keyword is being used to create a new object. So essentially, this is not a primitive type. Like integer 22 is a duplicate value, but a custom object or user-defined object with same parameters are not two same objects, right? So they have different they have basically different identity, and that's why your hash set is not able to detect that, and that's why it is not deleting the object. I mean, removing the duplicate. For hash set internally, these two Tom Hanks are different because their object IDs are different because they are two new different objects. Got the point? Now, as a part of this code, I want to have this feature that only Tom Hanks will be deleted, and I have the thing that I mean, I want to do the, I want to achieve this, that this duplicate should be removed. So how to do that? So you see, we have to override two methods. First of all, let us see this. Whenever, let me come to this part. So what happens over here is, when we are creating an object inside Java, we are giving a hash code, right? We are giving a hash code is being generated for that particular object, hash code for every object. Sorry. Okay, hash code for every object. Now, this hash code will be different for all the object, even though their parameter values are same. I mean, the data member values are same. This hash code will be different. This hash code is essentially your identity. Okay, and the hash set, right? The hash set data structure. Hash set data structure. What it does internally is, first, whenever you are inserting an element into the hash set, it will see the hash code method of that particular element, right? For every element, it will see the hash code for that particular element. Got the point? Now, once it gets the hash code, it will use this hash code to check in which bucket. So if you know the internal implementation of hash set, as Sir has already discussed, it is implemented as a hash table with multiple buckets, and one hash function is used to map it to one of the bucket. That hash function is nothing but the hash code, which is being generated by this hash code method. So this hash code method actually gives an identity, which is basically nothing but a string. You can call it as a string, right? As a string, it will give a random string. Not random, it is based upon a mechanism, but basically it will give you a string, the hash code method, which is basically its hash code. This is nothing but the hash code. This is the hash code method, and this is what we call the hash code. So this code, which is basically a string, will be given to each object. Hash set method will internally see this hash code method. Sorry, not the hash code method. It will internally call the hash code method and see the hash code for that object. This hash code is basically the hash function that is talked about in the lecture. This hash function will be used, and this string, basically this string will be used to decide in which bucket this particular object will be put into. Now, once the bucket is decided, let's say the third bucket. So let's say particular object is inserted, and the hash set is seeing the hash code of that object, and it is decided that okay, this hash code is this hash code, and depending upon this hash code, hash set decides it to put the object into the third bucket. So there is a first, second, third bucket. Inside the third bucket, let's say I want to put the new object, but let's say inside the third bucket, two other elements are there, right? Two other elements are already there. I mean, two other objects are already present inside the third bucket. A bucket can have multiple objects, by the way. Okay, so these things will be clear once you understand the internal implementation of hash table. But anyway, so there are multiple objects. So now the hash value or hash code of the third, I mean, so the new object is also making it to the hash code of the new object is also forcing it to be put into the third bucket only. So okay, so then before putting the new object into the third bucket, hash set will see that whether the new object is equal to these two already present object or not. So if the new object which is being inserted is equal in value to the either of these two objects, then it will not put the object, because this is equal and already present inside the hash set. And we know that we do not store duplicate values. But if it is not equal, then it will just put the new object as well in the third bucket. So, but how it is going to check the equality? I mean, I told you that we'll check for equality, but how it is going to check for equality? So these are the two things. So the mechanism you understood, right? I will come to that question's answer, how it checks the equality. So these are the two doubts that we have. Or sorry, not the two doubts, the two part in which the hash set is working internally. First, it will see the hash code. On the basis of hash code of the object, it will decide the bucket. Inside the bucket, if multiple objects are present, it will check the equality between the new object and all the objects present inside that particular bucket only. If the equality holds, then it will terminate the addition, it will not add. If the equality doesn't hold, then it will add the new object inside the same bucket only. So this is how this is happening, right? So the two methods which is working in this case is hash code method, which is defining the hash code, and this equality is being, coming back to the question, this equality is being checked by the equal method, right? Equals, I think, yeah, equals method. So these are the two methods, and the thing is both of these two methods are basically object class method, and any class will actually inherit these two methods. Now once these two methods are inherited, if we want to have a customized behavior on the basis of equality check and hash code generation, we need to override these two methods. So if I override these two methods according to the, since in our example we had this Tom Hanks thing, and we only want to have the duplicate behavior being judged on the basis of name, because that is the only field that is checking for me, that is there in the person class. So if I want the name to be the only field which decides the duplicacy between, the duplicate behavior between two objects, the equality, not the duplicate, the equality behavior between two objects, then I need to modify the hash code and equals method accordingly on the basis of only name. So that's what we will do in the code. Let us go back to the code now. Come to the person class. As we discussed that hash code and equal, if we want to override them, we have to override them inside that particular person class or whichever class we are trying to work upon, because every class will inherit person and hash, equals and hash code method, because those two methods are actually a part of the object class, right? So you see that I have commented this, and that's why the Tom Hanks was not working. Now let us uncomment this and go through the code. So see, here I have written hash code method, and we have written objects.hashcode this.name. So we know that we want to do the work only on the basis of name, but what is this? How is this working, right? So see, this is not something which is very problematic. What we could have also done is, rather than writing objects.hashcode. Okay, so let us do it in this way. Let us visit this objects classes method, then you will understand what's happening over here. So what is this objects class? So as you can see, this objects with an S extend the object class. The class consists of static utility method for operating on objects. Just like collection interface had a collections class, here object class has an objects class, right? And both of these have some utility methods defined, static utility methods defined, which will help us with operating in different cases, right? So this object class has a hash code method definition. So let us go to that hash code definition, see what's happening. As you can see over here, so this is the object inside the object class. Okay, so if you go to the top, you see the public final class objects. Okay, so this objects class, and inside this objects class we have this hash code method, which is basically accepting an object of type O, and it is checking if that object is null. If it is not null, then you call the o.hashcode. This o.hashcode is nothing but the object class native definition, right? Inside the object class, not the objects class. Object, the main hashcode method, as I told you, this is basically the part of object class. So this is the main hashcode definition of object. The implementation of this hashcode definition is native, and we are not going into that. But basically, just assume that this method is generating the proper hashcode for the object. Now, what are we doing over here? See, in our code, we are returning objects.hashcode this.name. We are passing the name field, that is the string field. So this object over here is nothing but a string variable, which is corresponding to the name. So we are calling o.hashcode, which is basically a string variable.hashcode, and that is being returned. Now what is this hashcode will return? It will return the hashcode corresponding to the object which is calling, which what object is calling? A string object is calling. So this hashcode will return a hashcode only on the basis of the string object. What is this string object? The name. So ultimately what is happening? This hashcode method will return a hashcode only on the basis of the name value that I have passed. This dot name value, which is there inside this object O, and therefore o.hashcode is being called, and this hashcode method will return a hashcode only on the basis of the name field. Okay, and yeah, so we could have also done this. This is the way it is done, but in most cases. But let me just, yeah. So that's why in many places, in many code, you will see this is the syntax used while overriding hashcode. That's why we have done this objects.hashcode method. But essentially, you could have already also done something like this. Rather than using this objects.hashcode, you could have written this dot name dot hashcode. Perfectly fine. Okay, so this is something very simpler. You are not using that some intermediate objects class. You can already write this dot name dot hashcode. So what it will return is, it will call the hash code method of the superclass, right? And the object class on the basis of the name field, and that's why the return code will only be on the basis of the name field. And this hash code method will return this value, and that's why we will have a object identity, which is the hash code of your person class only on the basis of this name field. Got the point? So see, now the beauty is the identity or the hash code of the object is completely based and solely based on the name field of the item of the person. So now if I have two Tom Hanks, their identity will be same because their hash code will be same. Got the point? Okay. Likewise, on the second overriding requirement was of equals method, right? And these are two just safety checks, right? If object is equal to null, return false. So if both the objects are same, I'm returning true. And what is the condition of that similarity or equality that I'm defining? So basically these two are just simple class check. If object is null, return false. So basically, obviously it will not be similar if the object itself is null. If the object belongs to a different class, then return false, obviously. This is where the thing is, main customization is coming, where I have typecasted this object because this is the definition. You cannot write person over here because according to the definition of the object classes equals method, remember this equals method and hash code method are, again I'm saying it is a part of object class. So since this is a part of object class, the object class is equal method, I cannot change the function signature, right? Object class mentions it in the form of object obj. So I cannot just write over here person obj. Right? I have to write object obj. These are the mistakes that people do when they don't get the correct result. You have to write object obj. You cannot write person obj over here. But since I'm writing object obj, I need to then typecast it over here, like we have done in the week 4 content lectures we have seen. So we are typecasting this into person and then storing it into person O and then using this O object to do our work. Right? So if you see over here we have this person, person O object, and then I'm writing this dot name equal to O dot name. So this is the customization that I'm doing. Only on the basis of name, the equality will be checked, not on anything else. So if this dot name equal to O dot name, then the object is true. I mean, equal is true. Otherwise, you return false. So it is not equal. Fine. So these are the two methods that we need to override. And now since we have overridden these two methods, and again go back to the same, we will not change anything in the main method. We just added two overridden method into the class whose object we are putting into the hash set. So now if I run, so you see now here earlier it was Tom Hanks, Peter Higgs, Tom Hanks. Now we have Tom Hanks and Peter Higgs only. So the second Tom Hanks is being deleted. Okay, so this is working properly. Now that there is just like hash map, there is tree map as well, and it will be done in the printed in the sorted order. Nothing else. Simple. I mean, you can remove all the key value pairs by just like dictionary in Python. When you remove the key, the values are also getting removed, right? So when you do map.remove key actors, then it will remove all the actors values as well. So and then you are printing the map to get the result. So if you see over here. Yeah, so you have the physicist over here, you have the novelist over here, and you do not have the actors, right? So, another thing is in the tree map, the sorting should be happening, right? So where is this sorting happening? So let us see that. Yeah, so this is the last part. So this is the tree map, first tree map getting printed as physicist, actors, and novelist. But sorry, the normal map was getting printed. Now the tree map, this is map 1, this is map 2. So this is the map 2 is basically your tree map. So you see the actors has come at first, right? Here physicist was earlier. But here actors has come at first. Why? Because by default, the tree map is sorting the value on the basis of the alphabetical order of the key values. No, sorry, not the key values, I mean the keys. So the keys in this case are physicists, novelists, and actors. So alphabetically, these are basically strings, and sorry, not alphabetically, these are basically strings, and therefore normal implicit comparison between them will be done on the basis of lexicographic order or the alphabetical order, and that's why actors will come at first in tree map, and then your physicist will come, and then novelist will come. So likewise in the tree map, actors are coming at first, then novelists are coming, and then finally physicists are coming. Okay, keep in mind that we are not sorting the values. If you see the values inside each of this, so there we are not sorting. DiCaprio, Al Pacino, Meryl Streep, Robert Downey Jr., Tom Hanks, those are not getting sorted. Those are in the order that we have put the value. Only the sorting is done on the basis of the key, right? Key fields. So this is where the tree map is a little bit different, where it not only stores the value in a dictionary kind of manner, but it also sorts them on the basis of the key fields. Okay. Yeah. So yeah, that's it for all the discussion. I have discussed all the fundamental technical things or the tricks that you need to do, like overriding hash code, overriding equals method, let's say your equality check and comparable interface, overriding compare to method. So these are the things that you have to you need to do to customize the workings of the collections. Okay, but all the methods of the collection which are implicitly given to you for utility, like first, add, last, there are multiple such methods. You can see them, you can explore them. That I will not go through one by one, right? But all the things that you have to do which are not given implicitly and you have to do in order to extract a functionality out of collections, all those discussions we have done. Okay, a lot of things were not discussed in the lecture because those part are coming to the technical aspect of it, the techniques while you do the coding, and not the object oriented ideas, but like this overriding hash code and all these things. But those will be important for you to solve the practice questions, and that's why it is very important for you guys to practice these things. Okay, so yeah, that's it from my side in this week's content. Hopefully it was helpful for you guys. It will be a bit little long, but I hope it will be helpful for you. So thank you all for this particular walkthrough session. We will meet you in week 7.